Welcome to Vitamin. Today we're gonna do the integral of inverse tangent of Lnx. First, to do this integral, we're gonna use our up. Let u is equal to Lnx. And then our du is equal to 1 over x dx. And then our dx is just, and to isolate our dx, just place e on one side so you can get x is equal to e power of u. So you can get dx is equal to e power of u du. So overall you will get e power of u times inverse tangent of this, right? Lnx is just u du. So how can we integrate this? E to the u times inverse tangent u. I'm going to use our integration by part di method. We're gonna differentiate inverse tangent x u. Because we are in the u, just be sure you put inverse tangent u here, and then we're gonna integrate e to the u. To integrate e to the u, you still get e to the u. To differentiate inverse tangent u, you get 1 over 1 plus u squared. So over this time that you get the first part of the answer is e to the u times inverse tangent of u, and then you're gonna subtract the integral of e to the u. Let me write as u squared plus 1. It doesn't matter the order. I'm going to combine to change them to the u row, to the x row, less on the last part. So I will do it later. Change to x row after I finish this integral, and this integral is very crazy. This is also a non-elementary integrals. So e to the u over u squared plus 1. The method doesn't work either. U sub doesn't work when it is an elementary. And this, we're gonna change this to a complex version of. Then we're gonna use our partial fraction. So I'm going to write this as u squared minus I squared. I squared is -1, right? Minus being positive, so you get the original. So you can write as u squared minus I squared. So you can just, let me just write as e to the u multiplied by 1 over u plus I, or u minus I first. U minus I times u plus I du. So you will get e to the u inverse tangent u minus e to the u. We're gonna use our partial fraction here. E to the u times u minus I plus u plus I. And here we're gonna use our cover method to figure out what's the constant here. Just cover it. How can we let this to equal to 0? Yes, you need to be I, right? So put I into here, 1 over 2I here, you will get. If you put negative I here, you will get 0 here. So put negative I here, you get negative 2I. So e to the u times inverse tangent u. I'm gonna just put the constant outside. Minus 1 over 2I times the integral of e to the u over u minus I. Split it to two integrals, and then minus means positive, plus 1 over 2I. And then times the integral of e to the u over u plus I du. And this is really hard. We're gonna use our what's that called? This called exponential integral. So I want this to be negative I here, and this to be positive I here. But it will change the whole thing. So we're gonna multiply by e to the I here, and then multiply by e to the negative I, so we can use the origin, get the original back. So this integral, I will tell you, this is just equal to, and the I don't like to be on the bottom, so multiply by I on the denominator and the numerator. So I will get on the here, so I times I, you will get negative, so you get a positive, plus I times e to the I over 2, and then times ei of u minus I, and then I times I become negative, so minus I times e power of negative I over 2, and then ei of 2 plus I. Because if it differs, is that you don't need to use the chain rule. Let's just get that. So here, just put it, what's e to the u? And the u is ln x, so e and ln, they cancel each other out, so we can get x here times inverse tangent of u is just ln x. Then plus I times e to the power of I over 2 times ei of ln x minus I minus, of course you can put the e to the negative I on the denominator, but up to you. Just I times e to the power of negative I over 2 times ei of ln x plus I. That's it. Very, very crazy. You see x times inverse tangent of ln x, and then we have exponential integrals here.